Hello everyone, I am Vishwa Mohan and I welcome you again on this video where we have been talking about the recursion. If you have not watched the previous videos, please go and watch where I have talked about recursion in detail. So far in this series, we have been able to have a good hold on the recursion. Recursion as a topic is super important for all the upcoming complex topics. In fact, everything, including the complex ones like dynamic programming, graph and tree. In today's section, we'll try to double down our understanding of recursion by solving few of the good problems from the LeetCode. Let's get started. Perfect. So the question is there on your screen right now, and the question says that generate parentheses. Now this is the LeetCode problem. If you have to go and find the problem over the LeetCode, just go and search with the name 22 generate parentheses LeetCode. When you go and do this, you'll be able to find the question on the screen itself. So let me go and open my Chrome where I have already opened my LeetCode. This is the problem which you see here. Let's go and read through the problem. So the problem says, let me minimize this a little. Given n pairs of parentheses, write a function to generate all the combination of the well-formed parentheses. So for example, if n is equals to 3, I should be able to go and print the parentheses like this. Okay. Let's try to understand this with the help of an example. So what the question is trying to say is, if I come here, right, it is trying to say that if let's say that n is equals to 1, is it possible n is equal to 1, only one parenthesis? Then in that case, the possibilities are only that you can make this and this. Fair enough. If n is equals to 2, it means that you have following possibilities, and with this you have to go and create the different possibilities. So one of the possibility could be that this is one of the arrangements, and the another arrangement could be, say for example, this and then this and then this and then this. The two possibilities, right? Anything else that we can do? No. If we try to do anything else, for example, if I do and try to do this and this, then this is not a valid, right? So I have to make sure that anything that we are making, it has to be a valid parenthesis, right? It has to be a valid parenthesis. Similarly, the example which is being shown here, for n equals to 3, I have to go and find all the possibilities, right? So one of the possibilities could be what? One of the possibilities could be, say for example, all 3 like this. That is one possibility. Another possibility could be, say for example, this, this and this. Another possibility could be, say for example, this, this and this. Correct? Another possibility could be like this and this, this and this. And the another possibility could be like this, this, this. Right? So a lot of manual efforts is being going on to solve this. So the question says that you have to solve this problem programmatically. You have to go and solve this problem programmatically. Now, if we try to little deep dive, we'll understand that there's some pattern in this problem. Say for example, if I take a case of n is equals to 2, right? N is equals to 2. It means that I have 2 starting brackets and I have 2 closing brackets, and I can use them to build my problem, right? So let's say that in the beginning I start with an empty string. Let's say that this is the logic that I have. And then I have 2 options. I can go and add the starting bracket, and I have used this. And I can go and use the closing bracket, but this is an invalid, so I don't use it, right? So one of the possibility, one C is gone perfectly. Now when I come to the C, then again I have 2 options. With this C, I can go and apply this C, or I can go and apply this C. Correct? So when I go and apply this C, I'm only left with what? I'm left with 2 closing brackets. And when I go and do this, then I'm left with how much? I'm left with 1 opening bracket and 1 closing bracket. Fair enough. Then again, if I go and do this, at this point, I have only one option left, which is, I have an option called as, typically, I have an option of closing this, and I have no other options, so otherwise invalid itself. When I'm this, then I'm left with only 1 closing brackets. And then here I have again two options left. One option is that it looks like this, and another option is that I can go and make it like this, but this is invalid, so it's not allowed. And when I go and do this, then I'm left with only one closing bracket. Then when I come again for the invalid, I have one option left as C, and C is like opening bracket, right? And then I have only left with one, which is this, right? And then I'm done. And the another one is not possible, it's invalid. And here also I have option called as this, and this is done, and another one is invalid. So at the end of a day, what you see that I have two possibilities that have been created from here. But at every step, if you see here, what you're getting is typically an example of a recursion tree. What I'm getting is an example of recursion tree. So what that means that this question could be solved using recursion. This question could be solved using recursion. So we'll try to apply this logic and try to solve it now. Let's see that how we can solve in the code, and then we'll try to come back and analyze that code. So now we have this LeetCode, and we'll try to start solving the problem. Now since here I don't have much support of the indentation and all, what I'll do is I'll go and copy this and paste that in my code, VS Code itself. So I'll go and paste this, and let's try to write the code here itself. So what I do is, let me go inside this and let me go and call it as let result, because I have to go and provide the multiple possibilities. So that will be an array of different possibilities. So I go and define result array like this, and then I go and define function backtrack. If you remember, in the previous question that we solved was also a classic example of backtracking. Here also we need to do the backtracking. Why we need to do the backtracking? If we just quickly see that, so initially it will be empty string, and then this is for example invalid, and then I do this, and then when I go and do this, then I go and do this, and then I go and do this. Once I'm done with it, I will have to go back, and then I will have to go back further, right? So that here I can actually go and apply this the other side. So every time you're done with it, you have to go back. This going back step typically is called as the backtracking. Right? So here also we need to do it. So that's how we go and define this function called as a backtrack. And here inside this, I will go and take a string. Let me go and call it str left and the right. Now str is basically the final string that we make with the combination of the opening and closing brackets. So I go and say that if length of this str dot length that becomes equals to, let's say that 2 times the size, because if that n is 2, then basically the number of total brackets will be 2n, because n is the opening brackets and then n there will be equal number of the closing brackets. So str length dot equals to, that is 2 into n. If that is the case, then this final response array that I have, there I go and push this s, and after pushing this s I can go and return, because I don't want to do anything. Fair enough. If that is not the case, what I do, I go and say that if left is less than n, because the left starts from the 0, so I only have up to, left is basically an counter of the bracket and also the index. So if f is less than equals to n, in that case what I go and call this function recursively backtrack, and then I go and say that okay, s plus this opening bracket, and then I go and say the left plus 1, and then I go and say that right. Or in the other case, if right has become less than the left, it means right has become less than the left, in that case what I go and make use of closing bracket. So keep on using the opening bracket till the time you can, and then only you go and make use of the closing bracket. Right? So right is less than left, I go and say that s plus closing bracket comma left comma right plus 1. So this is how my backtracking function is. Pretty simple and straight. And then finally what we do is that we go and call the backtrack, and I initially go and pass the empty string, and then I go and pass 0, then I go and pass 0. Right? And then finally what I need to do, I need to go and return this result array that I created. This result has to be returned. So what I go and do here is that I go and say return result. Let me go and copy this. So my code is ready. Let's try to go and put over the LeetCode and understand how it works. So I go to my LeetCode and I'll paste the code inside this. Perfect. As you can see here, I have written the code. Now let's try to run this and see if it works. So there is an error. What is an error? Okay. So I defined the string str and then I'm putting only s. I think that's the error. Str should be str. It should be str. Perfect. str.length. I go and pass str plus. Let's try to run this again. I'm purposefully not removing or deleting this from the edit, just to make sure that you guys get that things go wrong and then you don't have to get frustrated. You have to go and check it and solve it. So now I see that it has been accepted. Case 1, case 2, both are working fine. Let me go and click submitted. Please make sure that you are also solving these problems with me. You are able to write code yourself, submit on the LeetCode, and if you are able to do it, please tag me and tell me your success, that how you are continuously doing the progress in a journey of learning these LeetCode problems. Awesome. So I have been able to solve this problem. Great. What I need to do is that we can copy this code and let's try to understand this a little better. Right. So what I'll do is I'll go to my VS Code. I'll make it from here itself. Yeah, and let me go and paste it here. Let's copy this code and bring it to my open board here, and I paste in here. Now let's try to understand this code. Let's say that in the very beginning, I go and call this function like this, generate parenthesis 2. What that means that n value is equals to 2 now, right? And then finally, I go and call this function backtrack. And in this backtrack, I go and pass initial string as empty, and then I go and pass left 0 and the right 0. This is how it's called the first time when it is called. And the first time it is called, the value of the string.length is equals to 0, and this value is equals to 4, so it doesn't go inside this. I come here. Left value is 0 and value is 2, left is less than 2, so I go and call this function recursively again. And when I go and call this function recursively backtrack, right, so this time you go and pass this, so this step happens. So you go and pass here this, and then this value is 1 and this value is 0. Again, the next time when the function is called, you come here again. At this point, str.length key value is 1, this value is equals to 4. I don't go inside this, I come here. Left value is equals to 1, right value is equals to 2, 1 is less than 2. So I again come here. So I go and again call this backtrack, and this I go and again add. So this and this got added, and this value becomes equals to 2, this value becomes equals to 0, as you can see here. Right? Now again what happens? Again you go to the next time. Right? So in this, when you go inside, now at this point of time, the str.length value is equals to 2, this value is equals to 4, does not hold true, come here, this value is equals to 2, this value is equal to 2, doesn't go here. So I come here. Now right value is equals to 0 and the left value is equals to 2 and 0 is equal to 2, so I go and call this function this, and in this function what we go and do is I go and call it as backtrack, and in this case I go and add as this, and the value is 2 and the right value is equals to 1, which you see here. And then fair enough, again the next time the recursive call will happen. Again the next time when the recursive call happens, this value is still equals to 3, this value is equals to 4, does not hold true, come here, left value is 2, and value is equals to 2, does not hold true, right value is 1, left value is 2, so again it goes here, and then I go and add this, so again the backtrack function will be called, and this becomes 2, 2. When the next time when the function is called, again this value is equals to 4, this value is equals to 4, so it's done. So from here there is a base condition, and when the base condition happens, it comes back to the previous state. Now when it comes back to the previous state, right, at this position I was kind of done. At this position when I came here, this was here, right? So again I go back. When I again go back, so I am now left with at this position. Now when I go and left with this position, the value here is right value is equals to 0 and the left value is equals to 2, right? So I go and move to this direction, right? So this is how this whole recursion dry run happens, and as you can see here on this diagram, right, it goes and builds this, then again it backtracks, right, and then it goes to the next step, and then it finally creates this one. Please make sure that you are solving this problem and also doing the dry run as we have discussed right now. This is the recursion tree that will get created when we go and solve this problem. Now since we have solved this problem, we are all set now to go and solve another challenging problem. Now let's move ahead. So in the next problem, let's try to see what the next problem is. So the next problem says the problem of subsets. Again, if you have to go and find this problem over the LeetCode, just go and search in Google 78 subsets and you go and provide the LeetCode. Now this problem says that given an integer array nums of unique elements, so I have an integer array having the unique elements, return all possible subsets. The solution set must not contain the duplicate subset, return the solution in any order. Very nice. So it has also given one example. Let's say that you have been given an array called as nums, and it has the value, say for example 1, 2, 3. So what are the different possibilities of subset? All possible subsets. So saying one of the possible subset is there is no element, then I have 1, then I have 2, then I have 3, then I take 2 elements at a time, 1, 2, 1, 3, and then I should have 2, 3. Correct, 1, 3, 1, 2, and then I should have the 2, 3, and then I have all of them combined like 1, 2, and 3. So these are the all possible subsets that is possible out of this original one, the possibilities. These are all the possibilities that we have out of the initial top one. So now let's try to see that how we can go and solve this problem. So typically to solve this, let's say that in the beginning I have 2 elements, 1 and the 2. Now whenever it comes about the recursion, we should always try to see if the bigger problem could be broken down into the smaller problem, right? So one of the part of that could be there that, let's say that I go and I start with the subset of 0, no elements. Now then I go a little left and I can just go and add 1 element, right, and I ignore the other element. and then I can go further down where I go and take the other element, right? Let me do one thing. Let me take a bigger problem so that makes more sense, right? Let me take a number like it's 1, 2, and 3 itself. So in the very beginning, we start with something called as an empty, right? And then from here, I come here and I can go and choose the first element 1, right? So I have chosen 1. Then what I can go and do is that I can go down further, and let's say that I have two options. I can go and choose 2, that's 1. And then I go and see that I have one option which I have chosen 1, 2, and 3. And when I go and do this, I go back to the previous step and I go and call it as a backtracking. And then whatever, I have 3 left, so I can, I cannot use 3, so I have left 3. So this number is 1, 2. And once I have done, I can again go backtracking. Now in this case, I have chosen 2, right? So in another case, what I'm left with, I have not chosen 2. So this becomes equals to, and this is the state where I am only 1. Right? So I have chosen 2. I have not chosen 2. So this is just 1. And then here with 1, I have 2 options. I can go and choose 1 and 3. Because 1, 2 is already done. 2 is already done. So again, I go back. And then I have no other option left. So I'm only left with 1. Fair. Then again, you go and backtrack here where I go and say that, okay, in this case, I have chosen 1 and here I have not chosen anything. So when I have not chosen anything, then I can go, I have 2 options again. I go and choose 2. And with 2, then I have again left with 2 options. One of the options is that I go and choose 3. It becomes 2, 3, or else I don't do anything. I come here, I again go back. I go and say that I'm empty. I can go and choose 3, or I go and not choose anything. So all the leaf that you see here, this one, this one, this one, typically this one, this one, this one, right? This 6. Typically the leaves that you see typically, what you see, there's a recursion, there's a pattern. It's all the recursive pattern. And I'm able to go and print all the subsets of this. So we have understood that this problem could be broken down into the smaller chunks, and recursively I can go and create all the possible subsets of this initial one. So using this logic, let's try to write the code and then we'll come back and try to write on that. Right. So let me again go directly to my LeetCode. Here is the LeetCode, and the LeetCode, let me go and copy this and let me open my VS Code. We're going to create a new file. Let me go and call it as file save as, and let me go and call it as, what should be the file name, subsets underscore LeetCode underscore .js. Fair enough. Let me go and paste this. Fair. So now, first of all, since I need to have the multiples, right, you would have seen the pattern by now. I will go and call it the result equals to this. This is happening now with all the questions that have been solved. And then we go and define a function called as backtrack, function backtrack, and then I have subset, comma, start. Cool. We have done this. Function backtrack, subset, start. What I now do is, let me go and call it as result dot I have this res. Let me go and copy this. What has happened? Rush dot push, and then I go inside this and I go in there. A copy of subset. What this command does, So if I go and open my desk scribble, this command will copy the array and put it inside the array. It will copy the array and put it inside the array. Cool. And then what I do is, let me go and call a for loop. For let I equals to start, and then I want to say the I is less than nums dot length, and then I want to say the I plus plus. So what I do is, this subset that I have defined, subset dot push, and then I go and say that nums has a position I, and then I go and call this function recursively, backtrack, and in this case I go and pass subset same, and then I go and pass it as I plus 1. And then what I do, I go and say that subset dot pop, the last element which was added, just to do this. And this I do for the resetting the state. This I do for resetting the previous state. This I do for resetting the previous state. Fair. And what I do now is, this I have defined, we go and call it as backtrack. Should initial value is equal to 0. And once I have done this, I should go and return the result that I have. Did you go and copy this and see if this code works fine? I think by now we have already solved multiple questions in the similar pattern. It should be all very clear, but still we'll go and try to see how does it work out. So I'm going to put now this, I'm going to paste this here. And let's try to run this code. So there is an error. It is saying push num I. Why is that? Num is not defined. Okay. It should be nums. Fair enough. Let's try to run this again. So both my test cases have been passed. Let me go and click and submit this. Okay, so it is working all well. Let me go back and let's try to understand this code. So if I go and paste this code here, right? Let's try to dry run this, how this whole code is being written. Let's say that I have an initial numbers, right? So let's say the initial number is nums is 1, 2 itself. Okay, let's try to do the dry run. I am here in the beginning. I go and call this function backtrack. So this backtrack is being called. What is the subset? The subset initially that is passed is empty. So this is this one, and the initial value is equals to 0. When it goes here, it comes here first of all. So response dot push, and I go and add this empty subset. So this one of the response will be this empty array. Okay, then I come here for I equals to start, and so the start value will be equals to 0. I is less than number dot length. Number dot length will be equals to 2. This should run. I should go and say subset dot push number I. Right. So basically, at this moment of the time, the subset has become equals to 1, and then I go and call this function. So when I go and call this function the second time, backtrack, and I go and call this function second time, backtrack. This array has a value 1, and this start value has become equals to 1. Right? Let's try to delete this again. So the second time when it is getting called, right, when the second time it is getting called, I go and push this subset value. So this goes and print the value as 1, and then I come here to the next step. I'm here. So start value is equals to 1, nums dot length value is equals to 2, so 1 is less than 2, and again I go and do this subset dot push. So this makes it subset is 1, and then I go and push the element to the second, so it becomes 1 2, and then I go and call this backtrack. So from here again, the next time the backtrack is being called, and when the first time the backtrack is called, it's 1 comma 2, and this value is becoming equals to 2. Again the same story repeats. I come here, right, I go and add this. So what happens? This creates 1 comma 2. Fair enough. And then I move to the next one. Now I value is equals to 2, and this value is also equals to 2. So the for loop, it does not go inside the for loop. And since it does not go inside the for loop, what will happen here? It hits the base condition, and when it hits the base condition, it tries to go back. When it tries to go back, I am here at this position, and in this position I go and pop out. So at this position, when I go and pop out, this becomes empty, right? So this is my subset. And the second time the loop runs, when the second time loop runs, this value becomes equals to, this value was, at this point the value of the start was 1. Next time when it becomes equals to 2. So this is also equals to, so this doesn't come back, and it goes down. So it goes back to the previous step. Fair? Now when it goes to the previous step, at this moment of the time, at this state of the time, my subset is now this is empty, right? And I'm here, right? And when I'm trying here, it's nothing. It has no element left. It goes to the next point, and the value of I is equals to 1. And then I go and this value is equals to 2, so it goes and push 2, right? So at this point of the time, the subset value becomes equals to 2, and it calls this function. So from here again, this function is called backtrack, in which you go and pass 1, and the value of the subset here will be incremented by 1, so this becomes equals to 1. So now when it calls, right, you come here, you go and print 2. Then you come here, I value has now become equals to 1, this value is equals to 2, right? And you try to go and put the value. I think this one was already there, right? The next time when it comes, its value has become equals to 2, right? Its value will be 2 this time, right? So this doesn't comes here, so it goes back. And it goes back, it tries to go and emit it out, and finally these are the 4 values that gets printed. Please make sure that you're also doing the dry run code along with me when we are trying to solve these problems. So these are the 2 problems that we have solved on the recursion. Now we are kind of good practice, we are having the good practice around the recursion. Now going ahead, what we do is that every new concept that we're going to solve, every new topic that we're going to do, every problem, in order to master the recursion, every problem that we're going to do, let's try to solve in both the ways, both iterative and both recursion. So I believe all the questions that we have solved so far is enough to give us a good base. You don't need to solve immediately more number of problems recursion. It's time now that we move to the next topic in the next session. So we'll start with something called as mathematical problems. So in the next video, we go and talk about the mathematical problems in DSA. This will set our basics, right? Will set us for the more advanced problem that we go and do in the future. So in the next video, stay tuned, we'll talk about the mathematical problems in data structures and algorithms using JavaScript. If you're liking it, keep showing the love. Please share with your friends, because only your motivation of watching it more, your comments, your love motivates me to go extra miles. I'm doing 1,000 things right now to bring an amazing platform for you people. In few days, I'm going to announce the only platform, the only job focused platform in India which actually gets you the job, right? More than 50 job opportunities for everyone who enrolls into the programs and completes it. So a lot of things going on, but I'm still making sure that the free community content is coming non-stop on the YouTube, and for that I need a little motivation for you people and support. Thank you, and I'll see you in the next video.